Today we'll be looking at introduction to nomenclature in organic chemistry. Now, how to name organic compounds. That's actually what we're looking at, how to name organic compounds. So one of the most important aspects of organic chemistry is to know how to name organic compounds. Now, you must know the meaning of organic compounds. It's very important. And what we mean by hydrocarbons, and as well you must know the classification of organic compounds. You must know the classification of organic compound, and remember, organic compounds can be classified, maybe grouped majorly, maybe into four. We have the aliphatic compounds, we have the aromatic compounds, we have the heterocyclic compounds, and we have the alicyclic compounds. Now, aliphatic compounds, already know their definition. We are not doing definition of organic compound now. It's unlike compounds that have straight or branching carbon atoms. You can either have double bond or triple bond, like alkanes and alkynes. Those are examples of aliphatic compounds. And we also have alicyclic, that is a compound that have close carbon chains. Close carbon chains like cycloalkanes, cycloalkynes, and so on. We have aromatic, a compound that have maybe a deslocalized electron, or it has at least one benzyl ring. That is aromatic. Then the compound that have a ring and any other atom than a carbon atom in the ring, like nitrogen atom, oxygen atom, joint with the ring, we call it heterocyclic compounds. So all this, how to name aliphatic compound, how to name aromatic compound, how to name heterocyclic compound, how to know alicyclic compounds are very important when it comes to organic chemistry. We also have what we call functional group. Now, after functional groups, I also have what we call homologous series. Homologous series is a series of compounds successively divided by what we call CH2. Successively divided by what we call CH2. That is homologous series. And we also have functional groups. Now, you must know functional groups before you can be able to do well in organic chemistry. You must know functional group. It's very important. So at least you should know like at least 50 functional group in your head. Like a functional group of alcohol, a functional group of nitrites, a functional group of all these alkanes, the functional group of all these alkynes, functional group of alkanones, functional group of alkanoic acid, functional group of esters, and so on. You should know their functional group. What the functional group of cyanide, what the functional group of thiol, and so on. Now, the functional group is SH, and I think that is the functional group of thiol. And also have a compound that we call alcohol or alkanose. The functional group is OH, and it has just one single bond. So please, you must know functional groups. It's very important. It's very important. Very, very important. We also have different aspects like application of organic chemistry and the rest. But actually, we also have aliphatic compound and the reactions they can undergo. We have a lot of things in organic chemistry, and it's very important. We still have electronic theory of organic compounds. We don't know how to hybridize organic compound, hybridization of atomic orbitals to form a set of new orbitals that we call hybrid orbitals. Like most compounds, like all these alkanes, like methanes and all that, they are maybe they have sp3 hybridization, which is for all these alkanes and all that. You have sp2 hybridization, we have sp hybridization. Hybridization of organic chemistry is still very important in organic chemistry. We are not starting what we are here to do. I'm just explaining what you need to know in this organic chemistry, which is very, very important. We even have what we call isomerism. Isomerism is just like a compound that have the same molecular formula, isomers. Isomerism is a phenomenon in which you have compounds that have the same molecular formula but different structure. We have stereoisomerism, we have structural isomerism. Example of structural isomerism can be chain and branch isomers. We have functional group isomers, we have position isomers, we have tautomers, and so on. Well, but we also have the stereoisomer, which can be geometric isomer or optical. As you remember what we call enantiomers and diastereomers. Now, compounds that are not mirror. No, let us digress to isomerism. Let us digress to stereochemistry. Let us face the boss. We should know this, all those things, all these optical rotations. We should know them. It's very, very important. But let's just do this introduction to nomenclature and organic compound. Now, before you go into nomenclature and organic compound, you should know the rules we use in naming organic compound. Now, I cannot be copying the rules here. It's not possible. You should know the rules. If you don't know it quickly, just look for rules for naming organic compound. Although I will be quoting them, but I may not quote all. I may not quote all. Now, you also know preference. Preference, what you give preference to, or higher priority to when you are naming organic compounds. And we also have different functional groups. The functional group we give higher priority to when you are naming organic compounds. It's still very important. But there are 4 different compounds you should take note of before you go into this naming. The first one is the number A here, number B, number C, number D. They have different structures and they have specific names. Have specific names. Now, this symbol means this chain, this stroke, this line here, this bond is a continuous bond that is attached to a parent chain. Now, this one is going to a parent chain. This one is going to a parent chain. This one is going to a parent chain. Parent chain means the actual structure. This one is just like a substitute. All these ones are acting like a substitute. If something like this are acting as a substitute attached to a bigger chain, what are they called? That's what we have to look at now. Now, something like this, you either write it this way or this way, in which you have a carbon attached to the 2 different alkyl groups. So you just take note of the structure. This is called isopropyl. That's what we call it. Look at this. Let's say you have extend this one backward. Now 1, 2, 3, 4. This one is called sec-butyl. That's what we call this. And I write it this way or this way. Then this third one, this one is called tech. That is T-E-R-T. Tech-butyl. Tech-butyl. So this one tech-butyl. Tertiary butyl. Tech-butyl. Then this last one, that still have something like this inside. You check if you have something like this inside. Check it. This one is iso. This one is isobutyl. So this one is isobutyl. Just reflection from that iso to pi. So anyway you see something like this, it's called isobutyl. Now they can also present this in a form, in a condensed form, in which you'll be asked to analyze it. You should be able to analyze it to quote the date. To just quote the date. Now, we have compound 1 here, we have compound 2, and so on. We add to it later. Now, how do you name actually these compounds? How do you name these compounds? Now, before you name organic compounds, now these are just simple alkanes. These are just simple alkanes. Alkanes are not even here. Alkynes are not here. Now, if you want to name organic compound, we have rules that will follow. Now, if you want to name all these alkanes, alkynes, the bonds still count. The bonds are very important. Alkanes have double bonds, alkynes have triple bonds. So please, I will refer you to naming of organic compound, rules for naming organic compound. Please take note of them. It's very, very important. So now, let's assume we want to name this. The first rule you take note of is to number. You count the number of, or you note the longest continuous carbon-carbon chain to be called the parent chain of this compound you are seeing here. You note the chain that is long, the longest chain there. That will be the main name. That will be the parent name of this compound. Then you count. Now after you have counted, let's count 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. You count from one end to another, is CH3. That's N. Then you count from one end to another. That's how you do it. From one end to another. 2, 4 is the longest chain. 1, 2, 3, 4. So you count it 1, 2, 3, 4. 4 is the longest name, and 4 in alkane series. Since there's no double bond there between carbon atom, is alkane. So 4 in the alkane series is called butane. That's what we call it. Butane. Call it butane. So the name of this compound, we have 1, 2, 3, 4 as the longest chain. So we call it butane. That's what we call this compound. We call this compound butane. But we have other compounds then that are not along with the chain. They are not along with the chain. So the compound or the substitute, we call them substitutes. Any other compound or any other element can be presented like as a chlorine. Chlorine can also be here. Chlorine is an element. So and the compound or element that are normal, something like in line with the chain. They are called branch. They are called branches. So we call them substituents. So the substituents will be named first before you name the parent name. So how do you name substituents? So now this first substituent here that's not in language is called CH3. Now remember, CH4 means methyl. If alkane loses one hydrogen, it will form alkyl. So this one is called methyl. I don't call it. We call this one methyl. This one is CH3. We also call it methyl. I will also refer you to homologous series. You also know, I show you know homologous series. It's very important. Before you can even get it here, you must know homologous series. You must know homologous series, and it's very, very important. From 1 to 100, know homologous series. So this methyl, this methyl. Now the next thing, you number the carbon atoms in the parent chain and ensure that your numbering gives the substituents the lowest value. The lowest value. So you are going to number from both ends and choose the number that will give the substituents the lowest value. So let's check. Let's number from here 1, 2, 3, 4, 1, 2, 3, 4. So if you count from here, we have 2 and 3 in this place. If we count on this and have 2 and 3. So that shows that both of them are 2 and 3. That shows that the substituents are equal distance from both ends. So we are just going to do this one. So next, we are going to name the substituent first. We're going to name the substituent first. So if you want to name the substituent, you call the position in which the substituent is. In which the substituent is located. You call the location or the position. And you're going to, so like, after you have called the position, then you will replace the position with, if you have more than one substituent there, let's say you have 2 substituents, you are going to like call the number of substituents you have using all this di, tri, and so on, tetra, and so on. So let's say we have 2 substituents, the same substituent, so not two. If you have the same substituent appearing maybe twice, it's called di. We call it di before you call it substituent. So that we have 2 of this in this position. For example, now we have 2 of this guy in position 2 and 3. We are going to call it like that. Now, how do you actually write it? Now, I'm going to write it this way. I have 2. Now, if you have write this one is together in position 2. So you have the first one is together in position 2. Then the other one is, since they are the same thing, you call both of them together. The other one is together in position 3. So you write 3. Now, these 2 and 3, if you want to separate 2 numbers, because if you don't separate them, you call this 23. So when you separate 2 numbers now, you will sort, okay, let me write it here, let me write it here. So you have 2, 3. Now, you have to separate these 2 numbers. In organic chemistry, you want to separate 2 numbers, you use a comma. So you have 2, 3. And how many times do we call it? We are calling it 2 times. We have 2, 3. So we have 2 of them. So before you write the name of color is methyl, because how many number of times it was called? It was called 2 times, and 2 means di. Di, methyl, that's the name. Is there another one? No, then you now call parent chain butane. So the name will be 2, 3 di methyl butane. 2, 3 di methyl butane. That will be the name of this one. So let's go to the name of this. So you can't have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, we have 6 as the longest. We have 6 as the longest. The next thing, let's number. Number like this 1, 2, 3, 4. We have 2, 4. Number like this 1, 2, 3, 4, 5. We have 3, 5. So 3, 5 and 2, 4. Which one is better? 2, 4 is lesser than 3, 5. So I'm going to start from here. We have 1, 2, 3, 4, 5, 6. So we're going to have something like again. This compound, this substituent now, and these are not the same. That one is having 2. This one is just having 1 carbon. Now it is still losing. Any alkane that is acting as a substituent is automatically forming an alkyl. Take note of that. Most alkanes that form substituents to compound form, we call them alkyls. For example, now this one is not methyl, this one is not methyl. This one having 2 carbon atoms. Instead of ethyl, we call it ethyl. Because they have lost 1 hydrogen. So this one ethyl, this one is called methyl. Now, in another way, there's another one. If you want to call substituents, you follow them alphabetically. First thing, you locate the longest carbon chain to be called the parent chain. Then number to give. Then make sure the substituents, or you locate the substituent first. Then you number to give the substituent the lowest numbering. Then If any something repeat itself twice, you call it die. If you repeat it 3 times, call it try. And as also denote the location of these substitutes. It's still very important. Then next, you separate two numbers with comma and separate numbers and alphabet with a hyphen or dash. Still very, very important. Then next, before you call substitute, you follow them alphabetically. You call them out alphabetically. It's still very important. I already told you, go and look at the rules of naming organic compound. I'm just calling out some. So we also follow the rules. Then we have metai, itai. E comes first before M. So we are going to have itai. Before we call the itai, we call the location. Together number 4 carbon. That's 4 itai. Then 2 metai. And what's the name? We have 6 carbon, 1, 2, 3, 4, 5, 6. And 6 in organic compound means hexane. In alkane stage, we call it hexane, number 6. So 6 carbon atoms will give you hexane in the alkane stage. That's why I said you should also look at homologous. Let's start number 3. Look at number 3. Let's see, we have CH3. You have CH3. No, this CH will not be here again. You have CH2, then CH3. Let's go something like this. I want to name it. So the name of this one will be basically here. This place is closer to the something than that place. Let's do the one. We have 1, 2, 3, 4, 5. So we're going to have now this first one is CH3. So CH3. They are located in the same carbon atom. So you are not going to go. So we are going to fill about call for this is together 2 carbon, number 2 carbon, comma. So it's together in email number 2 as well, comma. Is there another one? No, okay, die. So what we now have 2 of them. So that means die. And what's the name? The name is what? Metai. And what's the full name? 1, 2, 3, 4, 5. And number 5, if you will go see this for K, is pente. Sorry, pente. So this one is 2, 2 dimethyl pente. That's what we call now 2, 2 dimethyl pente. Then let's look at some other examples. Let's look at this example 4, 5, and 6. Now, example 4 is using the same for locate the longest continuous chain. So let's check. We have 1, 2, 3. We have 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you see, we have 2 chains strongly for selection. So like you count like 1, 2, 3, 4, 5, 6. Also have 1, 2, 3, 4, 5, 6. But if you count it this way, this chain will have just 1 branch, and the branch will be complex. So if you have 2 chains completely for selection like that, we look for the one that have least branching. In which you want the branch, you don't even have branch again. Well, this branch is having another branch. This branch is another branch. This one will automatically become isopropyl, like that. But you cannot select that because we select the one that have the highest number of substitutes. You take the one that have the highest number of substitutes, in which this have like if you count like this 1, 2, 3, 4, 5, 6. So have just 1 substitute. Count like this 1, 2, 3, 4, 5, 6. So have 2 substitutes. So we are going to follow that one that have 2 substitutes. That's what we are going to follow. So to follow that, now we are going to count from the side that have 1, 2, 3, 4, 5. That is 4 and 5. 1, 2, 3. That is 2 and 3. So we are going to follow this 1, 2, 3, 4, 5, 6. So automatically this one becomes a substituent. So it becomes a substituent. We have 2 substituents here. So this one will be 2. Okay. Remember, this one is ethyl, this one is methyl. E first before N. So we're going to have 3 ethyl, 2 methyl. What is the name? Hexane. Number 6. You will not say this is hexane. So please take care of that. Number 6 you will not say this is hexane. So let's go to the next one. I have 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So there's a bond here. If you don't know, there's a bond between this and this. There's a bond here, there's a bond here. This is not shown in your question. There's a bond there. So we have 1, 2, 3, 4, 5, 6. This one is 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3. Okay, let's say 1, 2, 3, 4, 5, 6. Now it's 6. So the highest chain we have here is 6. We have 1, 2, 3, 4, 5, 6. So these two are closer to this end than that end. So we're going to start with this end. So the next thing, let's go to have how many substitutes? 1, 2, 3, 4 substitutes. 4. Wow. So we're going to be having this name. The name will now be. Now the first thing we do is to call the position. Now for this one, it's together in which type of position? 2. 2. This other one is together in which type of. Since they are the same thing, we are going to give all their position first. Then we'll call everything together. Not like we call them. No. Because this and this are not the same. That's why I call them separately. But everything here, they are the same thing. We are going to call everything together and give all their position together. So this one is still together in position 2. That is 2. This one is together in position 3. That is 3. There's also together in position 3. That is 3. Then. How many of them do we have? 1, 2, 3, 4. We have 4 of them. So what is 4? 4 means tetra. And what's the name? Methyl. Tetramethyl. 1, 2, 3, 4, 5, 6. Hexane. Hexane is over 6 carbon in the homologous for alkanes. And the next one is this. I have this. So this should be now. Let me quickly explain something. Now, if for example now the simplest member was what we call cycloalkanes from alicyclic compound. Alkylic compound are common from something like closed carbon chain. And this one, for example now, if we have something like this, okay, let me just give you an example of alicyclic compound. We have something like the CH3, CH2, CH2, and CH3. This is called butane. N-butane, that's normal butane. Straight chain butane. Then, if I now use this butane to form a closed chain, and everything will close. Remember, I can say butane, I'll bring this one here. So I'll be CH2. I'll bring this one here. So I'll be CH2. And I'll close it. This one will be here again. I'll be here again. So you now have 1, 2, 3, 4, still butane. But since it's a closed chain now, it's still butane, but it is not aliphatic, it is now alicyclic. It's now coming in closed carbon chain. So before you call the butane, you're going to not put cyclobutane. Not call it cyclobutane. That's what we call this one as cyclobutane. You also write it this way. You also just write it this way. So anywhere you see something like this, it means cyclobutane in organic chemistry. So if you see propane, then you see write it this way. You also write propane. For propane, you know propane is like the CH3, CH2, CH3. So we can just use to form a close. That is simplest way. We can close this one. Let's try and close and see. Let's say we bring this one here. Let's say this CH3, we'll go and bring it here. Will now be CH2. And this one will lose one hydrogen because this one will be CH2. So you see, this one is not close. So if it's close like this together, it's not propane again. We'll now call it cyclopropane. That's what I'm going to call it, cyclopropane. Then, for me to write it, I cannot place the sum of lines. I'll do it this way. And it will be like a triangle. So anytime you see a compound that looks like a triangle, it's called cyclopropane. So this one is called cyclopropane. Now, if you have a straight chain and a cyclic compound, now which one will take the lead? The one that has the higher carbon atom. So how many carbon atoms do you have inside? 1, 2, 3. How many do you have in the chain? 1, 2, 3, 4, 5. So the straight chain will take the parent name. So that's to name all this as a cyclic compound. I just put this one here so that you know that we are still going somewhere. So how do you know this one now? This will become a substituent and it's going to this number 1, 2, 3, 4, 5. So this will give us 2 cycle. It will not be propyl. Since it's not as a substituent. That 1, 2, 3, 4, 5. 5 is pentane. 2 cyclopropyl pentane. So that's what we're going to have in that side. So please ensure you subscribe to this channel. It's very important, and turn on our notification bell. Also look at other topics that involve organic chemistry. And there's some topic in chemistry, just in organic chemistry, like periodic table. Also try and read those and all, and ensure you examine yourself. So we'll see you guys in our next class. God bless you.